Good morning, my students. We are going to study the methods of transfer of heat energy through the substance. We are going to study the first method, which is called conduction. Heat transfer through materials by three different methods. Heat transfer through materials by three different methods. Number one, by conduction. Number two, by convection. Number three, by radiation. This is the first method to transfer of heat is called conduction. What is the meaning of conduction? What is the meaning of conduction? Conduction means heat energy transfer from high temperature to low temperature. If this body is a metal and this is a source of heat, heat transfer through it from this point to this point, from point to point, until it reaches to the end of the rod. Heat transfer from this, which has high temperature, to this, which has low temperature. This means that heat transfer from high temperature to low temperature, from high temperature to low temperature. By the transfer of kinetic energy between the particles make collisions and vibrates, so heat energy transfer from molecule to the next molecule. Heat transfer between the parts of the body. Hot side to cold side, transfer from hot side to cold side, or through the direct contact with objects that are touching. Materials that allow thermal energy to transfer through them quickly are called thermal conductor. Materials that allow thermal energy to transfer through them quickly are called thermal conductor. Those that don't called thermal insulator because they are thermal conductor. Metals are the best conductors of heat. Metal are the best conductor of heat. How can you prove this? By experiment. Give an experiment to compare thermal conductivity of 4 different materials or metals rods of the same size. If you have solid like copper, aluminum, iron, lead, they are different materials. This substance coated with wax. Each rod from it coated with wax. This is the wax which coated by it and placed in the same heat source. Boiling water is the same source of heat to give each one the same quantity of heat. Each rod is coated with wax and placed in the same heat source, like tank of boiling water. The apparatus is left for 10 minutes. This is the time. Wax is melted first on the paste conductor. Wax is melted first in the paste conductor. Wax is melted first in the paste conductor. This means that it is thermal conductor, has greater conductivity. Each rod is coated with wax and placed in the same heat source, like tank of boiling water, and the apparatus is left for 10 minutes. Wax is melted first on the paste conductor. Greater length of wax melts on the copper rod at first, showing that copper is the best conductor. More aluminum, more iron, more lead. Again, wax is melted first on the paste conductor. We observe that the greater length of wax melts on the copper. The greater length of wax melt on the copper. This means that it's the paste conductor. Another substance, like non-metal solids, tend to be poor conductors. This means that some materials may be conductor and another material not conductor, non-conductor, may be called insulators. Bad conductors or insulators. Good conductors, like metals. Non-conductor, like non-metal solids, tends to be poor conductors of heat, like glass, plastics, rubber, wood. Give examples for bad conductors or poor conductors of heat. Poor conductors of heat. Insulators of heat, like glass, plastic, rubber, wood, as well as material containing trapped air, such as wool, fiberglass, polystyrene. This is compounds, but bad conductor for electricity. Good conductors can be used in our daily life. Poor conductors can be used in our daily life. Example number 1, to show it. Metal handles of the peak are always filled of cooler than the plastic grips. Why? Because heat is conducted away from your hand by the metal and not by the plastic. This is a paper. This is wood. This is copper. Wood, bad conductor. Copper, good conductor. Copper, good conductor. Paper shares only where it covers wood. This is because heat received by paper wrapped over copper is conducted away through the copper to the interior copper rod. As a result, the temperature of paper of this part does not rise to its ignition point. Another example, in liquid state, in liquids and gases are poor conductor of heat. Liquids and gases are poor conductors of heat. Give example for it. By using this experiment, this is a test tube. This test tube contains piece of ice. And this is a source of heat, Make heating on this position. This is the boiling point. Water come out in the form of steam or water vapor, which move up and does not move down, so ice does not melt. Why? Water and heat goes up. Because by heating, volume increases and density decreases, because density equal mass over volume. By increasing temperature increases of liquid, volume increases. The relation between volume and the density inversely, this means that density decreases. This means that the hot water becomes upper, floats on the surface of water because it is lighter than water. Water boiling at the top while the ice has not melted at the bottom, which proves that water is poor conductor, but heat transfer through it by another method is called convection. But water, bad conductor, poor conductor for heat. Water, poor conductor for heat, because the piece of ice does not melt. We study solids, liquids, and gases. What about vacuum? Vacuum does not conduct heat at all. Why? Because vacuum has no particles. Because heat transfer by conduction from hot particle to cold particle due to the kinetic energy of particles, while in this case there is no particles in vacuum. This means that there is no transfer of heat through it. There is no heat. This is the first method. The second method is called convection. Heat transfer through solids by conduction from hot particles to cold particles, while another method to transfer of heat is called convection. This is the second method. Heat transfer through gases and liquids by convection. By convection. What do you know about it? If you have source of heat, this is the source of heat. Okay? This is water. These molecules becomes hotter than the molecules above or near the surface of the liquid. When the temperature increases, the volume of molecules increases and the density decreases according to the law, density equal mass over volume. Increasing volume, decreasing temperature, decreasing density. So it goes up. Hot molecules goes up and replaced by cold water. Warm water rises up. Cooler water sinks, goes up, molecules of hot water goes down, molecules of cold water. This is the method of transfer of heat by convection. When liquid or gas is heated at the bottom, what happens? It expands and becomes less dense. So it rises and gets replaced by cooler water around, which is denser, thus forming convection current. The transfer of hot molecules of water, warm water rises, this is called convection current. Convection occurs in gases and liquids only. In gases and liquids only. In a fluid, in gases and liquid only. Conduction and convection in water. In the first, heat reaches the thermometer bulb only. This is the source of heat. This is the temperature. Heat reaches the thermometer bulb only by conduction. What? By conduction. In this position, by conduction, while this position, by convection. What is the difference? No. In the first figure, heat reaches thermometer bulb by conduction, thus giving small reading. This is the low temperature when heat transferred by conduction. Giving a small reading, convection cannot occur from the top to the bottom, as warmer water, lead dense, remains above in the first. And the second figure, in this figure, the second, thermometer reading will be mainly affected by convection. In the first, by conduction, because the pulp near the bottom, while the pulp in this case immersed in liquid. In the second, thermometer reading will be affected by convection. As the warmer water rises to the pulp, the given large reading because heat transfer by conduction. By conduction, when the pulp close to the bottom. By convection, when it is when the bulb of the thermometer near the top of the tube, of the test tube. Convection is much faster than in the water. The thermometer therefore shows much more rapid increase in temperature. This function can be used in our daily life. This is some application of convection like refrigerator. In the refrigerator, convection of heat is used to circulate cooler air around the food. Convection of heat. Circulate around the food. Air is cooled by freezer. In the freezer, food is cooled. Compartment at the top of the refrigerator. Cold air sinks because it has more denser and gets replaced by warmer air rising below. Notice that convection will not take place if the freezer compartment is placed at the bottom. This means that freezer must be placed at the top of the refrigerator, not at the bottom of the refrigerator. Domestic hot water, another example. Water heated in the boiler rises by convection to the top of the storage tank, where the hot tap gets the hot water from. Cooler water in the bottom of the tank sinks down because it's more denser, so it sinks down to the boiler where it is heated. Storage tank is often covered in cheap insulating materials like polystyrene, which is poor conductor, which keeps the water hot for a long time. This is examples for convection or transfer heat by convection. This is some application for transfer of heat by convection. Goodbye and good luck, my students.